Now let's solve one more question and then we will solve this question with the help of MATLAB. Okay, so in this equation, first one is the double differentiation of y of t plus y dy of t. I missed y of t. Okay, so y of t by dt plus 9y of t is equal to 2 u of t by dt plus u of t. Okay, so in previous question we have seen that there is no derivatives in the right side of the equation, right? See this. So there is no derivative in the right side of the equation, but in this question we can find the derivatives in the right side of the equation. So how to solve such equation? See, first we will take the Laplace transformation of the entire equation. So the Laplace transformation of differentiation term is S. Okay, I mentioned here d by dt. Laplace transformation of d by dt is S. So this will be s square y of s plus 7 y of s, sorry, this will be s into y of s plus 9y of s is equal to 2 s into u of s plus u of s. So can we write this equation in terms of y of s by u of s? Okay, so I'll write this equation in terms of y of s by u of s. So what is y of s by u of s? This will be 2s plus 1 divided by s square plus 7s plus 9. Okay, now I will transform this y of s by u of s in form of y of s by x of s into x of s divided by u of s. So we can write like this. Okay, so this is equal to 2s plus 1 divided by s square plus 7s plus 9, right? So let's take y of s by x of s is 2 of s plus 1 and x of s divided by u of s is 1 divided by s square plus 7s plus 9. Now can we write this equation as s square x of s plus 7s x of s plus 9 is equal to u of s, right? So what will be the inverse Laplace transformation of this equation? Inverse Laplace transformation. So inverse Laplace transformation of this equation is d square x of t by dt square plus 7 dx of t by dt plus 9, sorry, this will be x of s, right? Because I need to multiply x of s in all the term. So this will be x of s. So this will be 9x of t is equal to u of t. Now what we have done in the previous question, we need to take x of t as x1. Okay, so what will be the differentiation of x of t? That is dx of t by dt. That will be differentiation of x1. So I will take this as x of 2. Then what will be the double differentiation of x of t? Can we write this as differentiation of x of 2? And we'll take this as x of 3. Okay, sorry, actually we don't need this because this is the last term, right? So we can write this equation as, or I leave this as it is. Okay, no need to mention this as x of 3. So we can write this equation, as x of 2 differentiation of x of 2, which is the double differentiation of x of t, plus, or I simply transfer all the remaining term to the right side of the equation. Okay, so this will be equal to u of t, or minus 7. What is the differentiation of x of t? That is x2. So this can be written as x2 minus 9. What is the what I have taken x of t, that is x1. So this will be x1 plus u. Okay, now this is our first equation. Now let's take the another equation. So I'll mention this y of t by x of s is equal to 2s plus 1, and we'll write y of t in terms of x of t. So y of s divided by x of s is equal to 2s plus 1, and we'll take inverse Laplace transformation of this one. So y of t will be equal to 2 dx of t by dt plus x of t. So I have taken x of t as x1 and dx of t by dt is x2, right? So I can write y of t is equal to 2 x2 plus x1. Now I will write all this equation in terms of in matrix form. Okay, so I'll take x2 dash, and what is x1 dash? That is x2. Okay, so x2 or x1 dash, and this is x2 dash, derivative of space vector. So x1 dash is x2, so this will be 0 1. This will be 0 1 because x1 dash is x2, and what is x2 dash? X2 dash is minus 7x2 minus 9x1. Okay, so this will be minus 9x1 and minus 7x2 plus 0 1 u. Okay, so we got the value of a and b, right? This is a and this is b. Okay, so what is y? How can we write this equation in terms of in matrix form? So y of t is 2x2 plus x1. So y will be 2x2 plus x1, right? So this will be 1 and this will be 2. Okay, so the y will be x1 plus 2x2. So I will tell you one shortcut method which can be used in GATE or in some exam. So shortcut method to solve this question. Suppose your Laplace transformation equation is given as in this form: b3 c3 s to the power 3 plus c2 s to the power 2 plus c1 s to the power 1 plus c0 divided by s to the power 4 plus a3 s to the power 3 plus a2 s to the power 2 plus a1 s to the power 1 plus a0. So how to write this equation in matrix form? So this will be x1 dash, x2 dash, x3 dash, and this is x4 dash. Now we'll write A, matrix A. So this will be minus A naught. I need to move in this direction, okay, in this direction. So this will be minus A naught, minus A1, minus A2, and minus A3. Okay, make it 0, and this will be diagonal identical matrix. Okay, now how to write this matrix? Sorry, this will be plus. We can write this matrix? This will be 0, 0, 0, and whatever common you have taken here, that I need to mention. So this will be B3. Okay, so in previous question there should be 1 because we have taken common here as 1, right? So this will be U, and matrix Y should be equal to, now just look at the numerator. I need to move like this. Okay, C0, C1, C2, C3. So this will be C0, C1, C2, and C3. So like this we can write by seeing the we can write this in space. We can write this space model. We can write this space state model in canonical form by using this shortcut. Okay, but in examination, in university exam, don't use this shortcut. You have to solve this equation with entire process. This is only used for gate purpose. Okay, now we will see these two question in MATLAB programming. Now we will see both the question in MATLAB. So in our first question, whatever the coefficient was given in the right side of the equation, we will take it as numerator, and whatever the coefficient we have in the left side of the equation, we will take it as a denominator. So first I will write numerator is equal to, so I'll write numerator. So what was the highest power of s? That is s to the power 3, right, because of dq. So from there we start. So s to the power 3 was 0 in the numerator, then s to the power 2 is 0, s to the power 1 is 0, and s to the power 0, coefficient of the s to the power 0 is 10. Now we'll write denominator. So s to the power cube coefficient is 1, then s square coefficient is 7, then s coefficient is 3, and s to the power 0 coefficient is, sorry, this was 5, and s to the power 0 coefficient is 3. Okay, now we'll find the transfer functions. How to find transfer function? For transfer function we use TF, and we need to find transfer function for numerator comma denominator. So this will give you transfer function. Okay, and let's say G. Okay, or we'll write closed loop transfer function. Okay, so this will give you the transfer function. Okay, now we need to find the state space representation. Okay, we'll write A, B, C, and D. Okay, so what is the value of these 4 matrix? So what we need to do, we need to convert the transfer function into state space, right? So transfer function to state space. See, this is very simple. Transfer function to state space. If we want to convert the state space, if we need to find the transfer function from the state space representation, then we will use state space to transfer function. Okay, but here we need to find transfer function to state space. Okay, so transfer function to state space of numerator comma denominator will give you the state space representation. Okay, See, this is in the controllable canonical form. Okay, I've explained you the two form of controllable canonical form. This is one of them. Okay, where all the coefficient is in the top row. Similarly, we can solve the we can find the state space representation of the second question. So let me clear this. Okay, now the right side of the equation, the coefficient which is in the right side of the equation, we'll take it as numerator. Okay, so what was the coefficient? 0, 2 and 1. Okay, now what was the left side of the coefficient? Coefficient in the left side of the equation, that is 1, 7 and 9. Now what we need to find? We need to find transfer function. So how to find transfer function? Simply we use def and we write here numerator comma denominator. Okay, so this will give you transfer function. Now we need to find the state space representation. So I'll mention here A, B, C, D, the state space matrix, and we need to find transfer function to state space. Okay, so I will put here numerator comma denominator, and this will give you the state space value. Okay, so one thing you can notice here in the question, while solving question, we got matrix A as 0 1 minus 9 7. Okay, it can be changed, the row can be changed, because you can there we have used x1 dash and x2 dash. Okay, that state vector differentiation of the state vector matrix. So you can use it as in the reverse form also, like x2 dash and x1 dash. Okay, so there is no problem in that. You can both the representation represent the controllable canonical form. So let's move on to the next topic in the next lecture. Thank you.